Hi, it's Grant from Dome Music Technologies here, and in this video we're going to have our third look at the ACE Integrator module. Now what I've got set up here is an audio rate rising sawtooth oscillator. So we're up in the audio time base here. We've got the slope set to a very specific value, which is 0.065928. which is a scaling factor which brings it to concert pitch. So at 0 volts into the ACE powers module here, you will get 1 volt out of here, and that multiplied by the slope value gives you basically middle C. So what we've got here is the initial volt is set to 5 volts, and we're using the plus 5 volt overflow to reinitialize the cycle every time. So it goes from minus 5 volts up to 5 volts, resets when it reaches plus 5 volts, back down to minus 5 volts, climbs up again. So it's just like the rising sawtooth output of a VCO in the voltage modular system. So if we just listen to what's coming out of the integrator at the moment, I think you'll agree that that's a very typical sawtooth wave. And what we're doing with the ACE powers module is we're taking the linear volts per octave pitch here and we're changing it into an exponential value, which is driving the linear volts to hertz system within the integrator, because we're raising it 2 to the power of the x1 input, so it's doubling for every volt increase, and double the frequency is up by 1 octave. So just if I bring in the actual VCO here and show you how that. So there's a slight tuning difference between them, but if we just play a scale on the keyboard, so that shows that you can use the integrator as an audio rate VCO. Now, using the sawtooth wave, you can derive all sorts of other waveforms, and there's one of the presets that came with the ACE collection. So if we just go into that, multi-wave VCO, here we go. So this all looks very complicated, but it's all quite simple really. So we've got the rising sawtooth like we had in that previous example, and that is coming from the output of the integrator directly. So the output of the integrator is going into the wrecker module, which is a fantastic one to grab for yourself. It's free from the VM store. It's fantastic utility. So we've got the rising sawtooth coming in here. We're getting a duplicate of it out here. We're taking the inverted output to give you the falling sawtooth wave. And then we're doing a bit of full wave rectification in order to derive the triangle wave. So it's coming out here, we're multiplying it by 2, and then we're dropping the voltage by -5 and feeding it in here. So we've got a nice bipolar triangle wave. And we have a unipolar pulse wave. And as you can hear, there's pulse width modulation on it. And we're using the ACE comparator to do that. So we've got the rising sawtooth wave coming into Vx. Vy has got a connection to this PWM in here, which is being driven by a triangle wave LFO. And we also have a bipolar pulse. So the unipolar pulse is from 0 volts up to 2.5 volts here. Increase it up to 5 volts. And bipolar pulse goes either side of 0 volts. So that shows that you can use the integrator as pretty much a fully featured typical modular VCO for audio rate use, and you can derive all of the other waveforms from it. The only one that you can't derive is a sine wave, but in a later video I'll show you how to create a very good, very accurate sine wave oscillator. But I think that's probably enough to be going on with for this video, so see you next time.